Hello everyone, welcome back to Tutoring with Interpret, and today we're going to talk about Gibbs free energy. So Gibbs free energy is a variable that lets you know if a chemical reaction is spontaneous or not. The formula for it is delta G equals delta H minus temperature times delta S. So delta H is a change in enthalpy, T is temperature, and delta S is change in entropy. So we need to get down a few principles before I show you a very easy chart to get this all done. First of all, if delta G is negative, the reaction is favorable. If delta G is positive, the reaction is not favorable. Think of it as a stone. If a stone is rolling downhill or on a negative slope, that's favorable. But a stone can't roll uphill by itself, so that's not favorable. Delta G is negative when delta H is negative and delta S is positive. Think of it using this acronym. So it's when life is spontaneous, delta HE double hockey sticks is negative and Sam is nice and positive. So when delta G is positive, delta H is positive and delta S is negative. And so you can see when this alternating positions, it's a certain yes or no. It's a positive or negative. But however, if you have both negative, negative, and positive, positive situations, we have to look at the temperature. A low temperature favors delta H, and a high temperature favors delta S. On the next slide, there will be a chart to help you understand all of this. So when you have positive delta H and positive delta S, you're temperature dependent or spontaneous at high temperatures. When you have positive delta H and negative delta S, you have positive Gibbs energy, and this is non-spontaneous. When you have negative delta H and positive delta S, you have negative Gibbs energy and you're spontaneous. So this is our perfect reaction right here, negative delta H and positive delta S. And this is our opposite, non-spontaneous reaction. And if you have negative, negative, you're temperature dependent, but you're spontaneous at low temperatures. So you can think of it as positive, positive, high temperature, negative, negative, low temperatures, spontaneous at negative delta H, and non-spontaneous at positive delta H. So you could take a picture of this chart. It's pretty helpful in answering questions that regard Gibbs energy. Let's look at an example to further our understanding. So this is a reaction and we need to find out how often it is spontaneous. So you can see that it goes from a solid to being aqueous. This means that the particles from being compact go to being free in a solution. This means that delta S increases. And since there's heat on the other side, endo, exo, it's exothermic. This reaction is exothermic, and this is a negative delta H. So delta H is going to be negative. Well, if you remember, when delta H is negative and when delta S is positive, the reaction will always be spontaneous. So this is always spontaneous reaction, or as the rock rolls down the hill. So that's pretty much about it. I hope you guys subscribe. It really helps my channel out, and let me know if there's any other topics you want to go over. I'll leave my email in the bio. And thank you for watching. Have a great day.